welcome. This is first class of statistics, right? The title is How to Conceive Statistics, right? And we will go over some basic concept and terminologies as a first class of stat introduction to statistics, right? All right, and you guys can use references, and we also had a last semester video. I will replace this video with this particular lecture, and I will include some specific direct citation with this quotation mark. And I will consider this as my lecture note. If you want to cite it and you're using it, this 2017 21st How to Conceive Statistic lecture note, right? All right, basic concept of statistics, and then we will talk about value of statistics and basic terms of statistics and level of measurement or scale of measurement. We will go over together, and I prepare some couple of takeaway thoughts and questions. And good news is we don't have analytical option for this first class lecture, but every other modules we have analytical options, and then we will go over together. And a couple of exercise I created in module 1, and if you click it, there's some video and PDF files related to this module 1 exercise has been uploaded in the course folder. And Q&A, there's some students send out questions, and I organize those questions and answers, and I also taped it. And you can watch what kind of questions students ask related to module 1 and module 2, and if those questions are not sufficient enough, and you can bring question, email me, or bring question to the next room, next class meeting. Right. First of all, let's talk about the value of statistic, because we are taking a stat class. We have to understand the value of statistic first, right? What is the value of statistics? Why we are taking it? We all agree we have to take it for our degree requirements, and people oh, I don't know, I don't want to take it, but I have to take it, right? Understandable. But number one, that's known, right? And we don't have to argue why do I have to take it, because some systems you agree to take it. But think about it. Why faculty members and our more senior person need to require this course? So that's very important. There's a reason why people require this stat course. Sometimes before you coming into doctoral program, sometimes as a exit as a master degree program, you have to take at least one course or start to take stat course. Why so? Considering the following newspaper headline: cigarette smoking cause lung cancer, tobacco industry deny charge, right? This is long history drama, right? Okay, I think there's a lot of people got a lung cancer, among smoker, non-smoker, right? And some people argue, look at this, and this is reason why we have to shut down tobacco company, but we failed to do it so far, right? There's lots of argument. I'm not talking about which argument is correct and right and wrong, right? And most of this argument, this important type of decision and argument and things, we are analyzing the phenomenon, and then also making a decision based on data and data analysis. And then we wanna do some kind of research or experiment, right? Even we are doing an experiment. Doing an experiment itself is not a statistic, but when we drawing a conclusion, right, analyze information from that experiment, we're typically using a statistics, right? So lots of piece of information, important information, and important argument, right? And that we are using a data. And then also that usage of data, the weight of using, making a decisions and drawing a conclusions, and incentive teachers and firing teachers, principals, and incentivizing this school district, right? And measuring data to promote our employees, and assessing the job qualities and job anxiety. See, the weights on their based on the data analysis getting a larger and larger over time, at least in United States. Do you understand what I'm saying? I'm not saying data is reflect everything, but usage and importance of those using data in important decision gets bigger and bigger and bigger than other area relatively to other area, right? So that's one of the core reason why we are taking this class, right? Stat. And formal answer is what? I would say ability to read and critique research article, because we want to consume what's going on without knowing a statistical model, right? And we have to believe them. Are you with me? We have to believe their conclusion instead of we critique and evaluate their work and critically, right? Sometimes I want to do that statistical analysis, not only understand someone else's result, but also I want to conduct some research. I want to do some experimental research and analyzing data, right? So in order to both, this is more like a consumer perspective. This is more like what? Producer perspective. You want to do both, right? This is introstat class, and we aiming for and both region. Not only you able to consume those analysis result as appropriate as possible, but also you able to do it if you want to do it. So this course is kind of challenging because we have to meet the both needs, right? But this answer is a little bit formal answer. It's kind of boring. Let me talk about my voice, right? And then my perspective is the why we have to take statistic, and what is value of statistic is to see the world correctly, right? See, nowadays, I mean historically, and we are surrounded by too many pieces of information, too many pieces of data. My mom said, my dad said, my grandma said, right? My cat said, my dog said. Oh my God, so many pieces of information. And what we want to know is what? What's a signal and what's noise? How to eliminate the noise out of the signal, out of the that and chunk, because chunk of information is include both signal we have to understand, also noise we have to eliminate. Are you with me? Statistical model produce give you very very nice analytical framework to eliminate noise, right, out of the data, and then you able to get the signal as efficiently as possible. This issue is getting a bigger and bigger because nowadays we connected everywhere. See, something happened in China, something happened in South Korea, right? And everything is connected. And my friends in South Korea is do know more than me about America. How about that? Because SNS and and the internet and media, and they just speed out the news on the whole world. Think about just the 50 years ago. Even you don't know, so you don't have to worry about what's going on in South Korea, right? And nowadays, even a little tiny thing, I get to know. Why? Too many signals and too many noises and too many pieces of information coming into me, because we are hyper connected society. This is a hyper connected society. Once you're connected, what happened? Too many data come to you, whether you like it or not. Cell phone, media, right? So what's your purpose need to do it? But we are same human being 50 years ago nowadays, right? And we have limited capacity to processing that piece of information in our brain. Are you with me? So in order to processing that many tons of data, and we get what? Help from statistical model to eliminate those noises to understand the signal. So use a statistic. Consider statistic as what? A type of analytical method, right? to eliminate errors, residual, noise, right? To the signal what you are looking for, right? And then isolating two things from the chunk of data, right? That's number one. Another one is getting over this prejudice. See, once we decide to do it, we want to see the world as much as as we want to see. Once again, we will see the world as we want to see. Some people said the world is a triangle, but you hate triangle. You don't want to see the triangle. That is what you cannot see the world correctly, right? One way our brain is what so ego type of thing. You can't see the world correctly. So one way to overcome this bias, personal bias, I want to see the world what I want to see. I want to see the world as it is. One more time. We want to see the world as it is. In order to get rid of that what? Bias, prejudice, personal prejudice, right? And I know belief is good, right? But sometimes too much. We want to see the world as it is. And from time to time, we are using this statistical model. Using a statistical model, we want to see as it is. Try to isolate our personal belief or personal experience as much as I could, right? And I'm not saying personal belief and personal experience is not important. Sometimes we want to separating two things out. Are you with me? We want to see very objectively as well. Sometimes I'm all in. We have to processing that information very very what subjectively. I fully support. But sometimes you want to see the data objectively to evaluate the things correctly, right? Temporarily, at least temporarily, right? So, and then third reason why we need to learn statistics to overcome uncertainty, model uncertainty, or dealing with uncertainty. See, math, difference between math and statistic or probabilistic is what? Mathematical world is deterministic world. Are you with me? Everything will be determined by some rule and logic, right? Statistic is different from mathematical perspective. It's okay to model those uncertainty, not okay to model. We like to handle, we like to control those uncertainty when we drawing a conclusion, right? We are accepting those, allow those uncertainty, build those uncertainty component into our decision. So you're a math person, right? Wrong. Equation. Everything's wrong, right? In statistic, we will say, you know what, the chance of that this thing is true will be this much. I mean, this is very statistically likely to be true, right? But we are not just saying but we are providing that chance or likelihoodness using some computational method, statistical model, right? And probabilistic model. So we are dealing with those uncertainty instead of, we just don't believe and such uncertainties exist, right? We understand uncertainty exists and that we want to handle those uncertainty. That's the whole value of why we have to learn statistics to see the world correctly. If we able to see the world correctly, what happened? We able to live our life better. Are you with me? We able to live our life better, a lot better. Sometimes you can make, if you apply this statistic in stock market, right? You have a better chance to make money, right? If you apply this one to your high school, your school data process, you can see the world much more efficiently and appropriately and validly and also reliably, right? Data is one piece of the truth. I agree, but sometimes it helps if you can handle those even limited, stat process if you apply it more, appropriately, right? All right. Next section, basic terms of statistics. Population. The first terminology of population is what? The all members in a well-defined A group. So you have to define a group. What is population? My population is fifth grade students in United States. Cool. But fifth grade graders in United States will be nested within all graders in United States. You are saying what? I am, right, only interested in sixth graders in United States. That means you systematically, deliberately exclude non-United States, another grade, etc., etc. You have to define population, and especially in what? In inferential statistic world. Parameter is, we call that as a characteristic of population. What do you mean by characteristic? Size of population. How many students in sixth grader in United States? What is math score averages of all sixth grader United States, right? Whatever characteristic, right, of that entire groups, right, size, averages, and the this averages, the other averages will be parameter. So we might have a multiple parameters if you have a many things are you're interested in these groups, right? Sample is subset of the population, the population you define. Whenever you want to talk about sample, sample is should be a subset, right? So you have to define its sample is depends on the population, right? So if you decide to the cat, for example, cat is a sample of all animal as a population. Are you with me? Right? And then the cat, right, may have a many subpopulation. American short hair, right? Or a fancy cat, right? There's a multiple types of cats inside of that one, right? So if you have a subgroups, and we call it as a sample. How we create that sample is different story. Whatever subset, it automatically become a what? Subsample, right? So example of sixth grader in United States, boys will be a subset of sixth graders of United States, and girls will be a subset of the that groups as well, right? So you can divide by it into two subset of all sixth graders of United States. Statistic is now as a parallel to population to parameter characteristic of that sample. So this becomes what? Oh, average of American short hair cat, right? Average of size of American short hair cat. And another, or average of what? Math score of females in sixth graders in the United States. All those things becomes what? Characteristics of a sample. Once again, you have to define the population. At some point, you have to define it. Why? Oh, sixth graders are nested within all graders. All graders are nested within K-12 in the United States. And all those K-12 students in the United States nested within all K-12 students the whole world. Cool. All K-12 students the whole world is nested within all humans in the world. Cool. All humans in the world is nested within all animals in the planet. Cool. All animal in the planet is nested within all things in the world. Cool. All things in the world is nested within all things in outside of this, earth, right? Cool. All things. See how many times we have to do it. Somebody at some point you have to decide the population instead of you said everything in the world, right? It's impossible to analyzing everything in the world, right? So you have to constrain you have to well define the group. Descriptive statistic, there are two different type of statistic. We will talk about this one separately later. But descriptive statistic is what? You're using statistics to describe and summarize that data. Inferential statistic is you're drawing a conclusion and statistical guess and statistical guessing game. You're drawing a conclusion to the population parameter using a sample statistic. If we use that way, and we call it inferential statistic. Why? Look at this. Do we have every information? No, we are human being. We are human being. We are limited. Even though we do our best gathering data as much as we could, but those data is what? Very limited. It's just a sample out of the entire possible information. Are you with me? That's the reason why whenever we draw a conclusion based on our empirical beautiful data, still it's not a perfect set of information. It's a partial piece of information. Are you with me? So 99% is, well, unless you artificially define the population data and like a census, 99% of our conclusion is what? Guessing, statistical guessing. I want to believe to the population information primary is this using our sample data. Are you with me? So it's very, very important techniques to understand. Once again, statistics, there's a descriptive statistics, and we want to describe, and we want to summarize, and we want to aggregate because a whole bunch of numbers is not enough. It's too many piece of information, and we want to represent that piece of information in a what? Easy to understand. So chart, table, mean, median, standard deviation. And then we just tease out lots of characteristic of from the data to describe what's going on. Right? Inferential statistic, once again, we always had a what limited piece of information, sample data. We don't have access to entire population data level, but we have a sample out of population. But still we don't want to limit, oh, this is what things going on in this data set, but you want to generalize what to the entire sixth grader in the United States. Once again, you collect beautiful 5,000 sixth grader students' math achievement. That is math achievement of that 5,000 students. Are you with me? It's not, but you want to draw a conclusion. What's going on and what? Math achievement of all sixth graders in the United States. But you don't have data. You only have a 5,000 data, right? But when you want to appropriately infer, we call it a generalize, right? Externally represent, generalize to the population using sample information. That's inferential statistics. That business is inferential statistic business, right? Because I want to draw a conclusion at the level of where? United States level, even though you only have a 5,000 sample size, right? And inferential statistic is how we appropriately drawing a conclusion at the level of United States, right? Statistical guessing game. Population, given population, characteristic of population will be parameter. We will sample out of it. And then what? This is a subset of the population and characteristic of this sample, we call it as a statistic. Inferential statistic, we have many samples. Listen. If we have this random sample, the other random sample, this sample, that sample, right? Even though every subset is came out from this population, they're not exactly same. They're all water baskets, right? But their size is not exactly same, right? And then we want to draw a conclusion out of those things. Sampling is a process of getting that population, subpopulation. Once again, sampling is a process of getting subset. Are you with me? Process of getting subset. Sampling error is this because it depends. Sample characteristic will be depends on each sample. They are varying. Even though this subset is came out of from the exactly same population, there are what? changing. They are jumping around. Are you with me? That's the whole idea of what? It's a sampling error, right? Why we will have a sampling errors, right? The reason is the process of the way of we getting our sample is a random. If there start to fluctuate, the characteristic of sample will be fluctuated. Let me give me an example in this. Look at this. You randomly select, for example, five students from the sixth grade or your school, and then you compute the average of that five students, and then you do the another random five sample of five students, and that average is different from the previous averages, right? The averages of each sample, which is statistics, are what? Different from each other. Are you with me? So in that case, what we call as there is a sampling errors associated in that sampling process. There's a methods of sampling. There's one, the definition is what? First of all, sampling. Second of all, sampling frame. Third of all, sampling bias, right? And sampling selection bias is when occurring when part of sampling is not in the sample, because the process of sampling is not represent entire population. In that case, we call it a selection bias. We will talk about those more, the bias and threats to the experimental research later. All right, cool. Types of sampling. There's a multiple types of sampling. The first sampling is convenience sampling. Convenience sampling is you just gather the data as much as you could. There's no randomized component, right? This is least generalizable. Again, you collect 5,000 sample size. If you choose convenience sampling is what? I don't know. I just go ahead to collect the 5,000 sample size as much as I could, right? In that case, we call it that sampling method is what? That sample or that sampling method is convenience sampling. And the conclusion is least generalizable. Let me tell you why. Even though you have a 5,000 data set, the things going on in that 5,000 data set is only business on that 5,000 data set. There's no guarantee, right, to understand what's going on entire population. Is very, very, I'm still Voice of America. Look at this. This is 5,000 Voice of America, and everybody, pick up the phone call, right? And they're writing in the choose the right candidate, right? It is Voice of America, but Voice of America limited to that particular sample. Are you with me? It's hard to generalize whether that Voice of America is represent the entire United States. Are you with me? This is very important. Politicians, right? And big brothers, right? And they always talk about that representativeness of our voices, right? And they're doing a statistical method sometimes, right? And we want to know what's going on, how to dealing with this representativeness. In America, it's very, very important. Representativeness is a big deal, right? And generalize, we in statistics, we call it as what? Generalizability, right? If we, the method of gathering those data, if we go with the convenience sample, we collect the data as much as we could, whatever we want to do, we call it as a convenience sample, is very, very not general and least generalizable than others. So what's your conclusion? What's your question for now? What is better or more generalizable method to collecting data, right? We start with the simple random sample. Simple random sample is what? Given population, we need to have a list of population, every members, right? And then what? Randomly select, probabilistic select, right? Subset of them. When we select, we assign each dot has exactly same population being selected, and then randomly select out of it. Are you with me? So in order to do it, Mathematically, one more time, we have to assign, first of all, we need to get a complete list of entire population, number one. Number two, we have to assign exactly same probability of being selected for everybody, and then select 5,000 and 2,000. And then we call it as what? That process is simple random sample. Okay? Or random sampling. Are you with me? This is if why we are doing random sampling, in order to increase generalizability of our conclusion. Why? Because samples start to more externally representative or more generalizable. The sample becomes more generalizable, our conclusion becomes more generalizable. Better than convenient sample, right? Second one is stratified sampling. For example, oh my God, Chewa, now I need to have a list of entire students in whole world, the entire United States, sixth grader list. I don't have it. But each state department, they have it. Are you with me? Each state department, they have it. So we know which state, how many states in United States, right? And we, first of all, we divide entire population into subpopulation, all right? And then randomly sample out of each, subgroups. Why? Because each state department, they have a list of students, right? And then we just randomly select them 50% of each state department. Are you with me? That is stratified random sample. Strata, we create the strata first, right? And then random sample each strata. Are you with me? So for example, school district example. So do you, school district, right? Each school maintained students list, right? So we create subpopulation, subgroup as what? Entire state department. Oh, school A, B, C, D. School A, B, C, D becomes what? Strata. And then you randomly sample each school. Are you with me? Instead of you have a gigantic list and then doing a random selection. Each school, you randomly select, right? Next one is cluster sampling. It's very similar to stratified sampling. Cluster sampling is what? The same thing, randomly select groups. You subdivide by the entire population into cluster. No. Yeah, cluster. Still subgroup. We don't call it a strata. We call it a cluster. But you're not doing it. You randomly select a cluster. For example, school district. You are randomly select school. You are not visit every school. You randomly select the school. Oh, I have 50 schools. I only select 10 schools out of 50 schools. You randomly select the school and then doing a data analysis for each selected schools. Do you understand the differences between stratified sampling and cluster sampling? One more time. Cluster sampling is what? You visit every schools, and then each school you do the 50% and random sample. So you have to visit every schools. You have to visit every states. Are you with me? That's a stratified sampling. Cluster sampling, you are not gonna visit every schools. You randomly select schools. You are not visit every state. You randomly select the states and then collect the data. That's a key differences between stratified sampling and cluster sampling. So please understand that key differences. Variable, types of variable. Variable is the characteristic which is varying. The constant is the characteristic which is constant. It's not varying. We call it as a constant. For example, what is characteristic of human being or not in my data set? Everybody's human being. It's no cat, right, in your data set. So status characteristic is this person human or not in your data set? Everybody is human. No alien, no cat, no dogs. So that piece of characteristic becomes what? Constant. If you decided to analyzing, right, female sub-analysis, every subject in your data set is female. So gender becomes what? Constant. It's not varying in that data set. Are you with me? Gender is not varying in that data set. But male or female will vary in other data set, right? Sometimes the characteristic of that data set will be fixed, right? Female study. Of course, everybody's female, right? Even you have that gender characteristic, everybody's female, right? Discrete variable is a variable had only, right? Some numerical variable have take only certain value. 1, 2, 3, 4, 5. That's it. There's no 1 to 1.2. For example, you have what? How many students in my data set? There's no 1.2 students. Are you with me? There's no 1.7 students. Once everything's to be, count data should be what? It should be integer. Are you with me? Continuous variable is what? For example, your height. Even our measurement limited to 6.1, 6.2, 6.7 looks like a discrete, but we understand that there's some scores exist 6.1 and 6.2, right? In terms of height, right? So in that case, that kind of characteristic of variable, we call it continuous variable. Same numerical, metrical, but the possible value exists in between two values. Continuous variable. Sometimes there is no possible value in between two variable. 1.2 human being doesn't make sense. Maybe pregnant. I don't know. 1.2 person doesn't make sense, right? The commonest variable is a special case of discrete variable. We only have a two status, 0 or 1, right? And then only two value available, and then we call it dichotomous variable or binary variables. These are just the terms and definitions. Independent variable and dependent variable. See, there's two different variable. One variable and two variable, but not just two variable. You have a theory, listen carefully, you have a theory, the one variable, a variable, affects on the second variable. In that case, right, this variable we call as independent variable. The arrows comes in, we call it a dependent variable. For example, math anxiety and math performance. See, and you want to set the theory, not just the two variable exist. Math anxiety, you believe, do affect on math performance. In that case, you have a theory, and then you call it as a math anxiety as what? Independent variable, and stat final exam performance will be dependent variable. You're interested in how math anxiety affects on their stat final exam scores. And that this relationship could be research question. Are you with me? One more time. What is independent variable? A variable, the causal inference coming out. What is dependent variable? The causal inference, this arrows comes in. So sometimes we call it endogenous variable, exogenous variable, and that kind of way, right? Endogenous variable, exogenous variable, right? So independent variable, dependent variable is right term in this class. Operational definition and measure, right? The thing we like to measure is not as easy as the measure height, measure weight, measure speed, right? If we are interested in to measure those height and weight, length, right? That kind of stuff, we have to go to Home Depot. There's a tons of scales and measures and produce very reliable data for us, whatever we want to measure, right? But what's going on in this psychological and educational area, social behavior science? What's the biggest concern? Because the things going on is in here. Are you with me? Our anxiety, our math achievement, our intelligence. The thing we like to measure is what? Not directly observable. We must use what? some measure data, right? And then to instrument to measure those abilities, right? So we call it as what? We need operationally define the construct. One more time. The thing we typically interested in social behavior science is not directly observable, not empirically observable. We can't see the size, so we must understand the size or levels or status using instrument. Are you with me? So we must have scale to measure those construct what we are interested in. So this is kind of confusing because a lot of statistical examples in social other, they don't worry about in hard science, they are not worried about this construct. But this is very important for us. We need to have a good, reliable instrument to measure the thing we are interested in is mostly what? Human characteristic, attitude, anxiety, right? Loyalty, right? Ability, intelligence, right? Capacity, right? That kind of stuff is we are interested in to analyze in social behavior science, education and psychology and human development, right? And then in order to do it, we need to have a good instrument to measure it, right? But developing developing those instruments related to operational definition. Anxiety is easy to say, whoa, anxiety. But how you operationally define anxiety? Oh, it's easy to say math ability. Oh, method. Yeah, how you operationally define math ability on that group in that particular population. That's a different story. That's a different story. Are you with me? So that's big deal for that's the reason why we have a assessment and measurement and testing certificate and master degree who want to be a specialized in that particular area. All right, this is a summary of definitions, and then you can go over those definitions and go over it. All right, labels and scales of measurement, and we will repeat this one more time, but let's do it very quickly. You know what? Funny thing is, my fifth grader kid's name is Ethan. He talks about nominal, ordinal, interval ratio, median, and mode. And today, Appa and Daddy, and then I take some exam, and he's fifth grader, and then he talks about those things, right? So let's repeat one more time. And fifth grader contents again: nominal, ordinal, interval, and ratio. I mean, if you're not get through those training in United States and you may not, but nominal scale is what is exactly same as a back number of sports athletes, right? God never told us why he got a five, number five in that particular groups. It's a nearly same as what naming. That's the reason nominal is the same as a naming. Even though we put numbers on the back of the sports athletes, and it works as a name. Oh, number five, number seven, right? It's not like a number 10 is two times faster than number five back number students. No, number represent it's a name, nominal scale. Are you with me? We're systematically adding some numbers, but it just happened to be what name. Ordinal is a we assign number, but number represent ordinality. 1, 2, 3, 4, 5. Oh, 5 is best, or 1 is best. Directionality is not important, but number increasing representing some characteristic order. Are you with me? So grade is what? A as 1, A as a 4, and B as a 3, and C as 2, right? Sometimes we adding a numerical number A, B, C, D, GPA. That's representing what? In general, it's an ordinal scale. One, higher number representing higher something, but that difference is the number not representing that differences in that construct level domain. Are you with me? That's a very, very typical thing. Ordinal scale example, rank order is one of the great. Oh, he's top. That's it. He's a second. He's third. But the difference between first and second is not exactly equally spaced on the 2 and 3 and 3 and 4 and 4 and 5. Are you with me? It's just representing what? Rank. Rank came out of from the GPA, right? Interval scale, now getting a little bit challengier. Interval scale number represent metric is meaningful. Number start to represent something. So one, somebody need to define what do you mean by one. 1 inch, one one the 1 second, right? One more dollar, right? The unit is meaningful. We call it as what? Metric. What do you mean by two? Oh, $2. Oh yeah, now I understand what do you mean by two more. $2 more. What do you mean by three more? Oh, 3 inch more. Now I know what is 1 inch, right? So number start to unit represent something. We agree onto that unit. $1, 1 inch, 1 second, right? One more basket, right? We we do understand the meaning of metric one, and then that's okay. And then it becomes interval scale. But interval scale, the challenging part is what? Interval scale and ratio scale, both metric is meaningful. But ratio scale is a special case of interval scale, zero also meaningful. Wow. One more time. Ratio scale is a unit is meaningful, zero is also meaningful. What do you mean by zero is not meaningful? Interval scale, zero can be anywhere. At a certain point, we have to decide this is a zero. Are you with me? But ordinal scale, there is absolute 0 point in ordinal scale. I mean, ratio scale, right? Zero weight is what? Zero weight. Zero height is a zero height. You can't change a zero anywhere. Zero means something. Interval scale, zero need to be defined in somewhere. We are making a decision, a certain point as a zero. But ratio scale zero is what? Absolute 0 point exists. So let me tell you this, make it simple. Every numbers came out of physical domain, also empirical domain. We call it as what? Ratio scale. The numbers came out of our construct, psychological domain, likely to be what? Interval scale or ratio scale. Are you with me? One more time. The numbers came out from our anxiety, and what do you mean by zero anxiety? God never told us zero anxiety is no anxiety at all. No, somewhere in that continuum, we need to call it a zero anxiety, higher and lower. Are you with me? So that case, if we develop kind of instrument in psychological domain, cognitive domain, it's likely to be what? Interval scale. If you process these numbers from physical domain, which is speed, height, weight, right? And that is likely to be what? Ratio scale. Why? In physical domain, there is a zero. Interval scale, we artificially create that 0 point. Boring. Yes, thank you. This is a summary of those things, and we will talk. You can just review those things one more time. All right. I want to organizing some. If you take away thoughts and question, it will take 15 minutes. Hold breath, and then we have a last moment of, this lecture. Statistics, mean, variance, standard deviation, covariance, correlation, blah blah blah. Right? Scary, right? Even I don't even providing equations. Right? It drives us crazy. Oh my God! Pearson product moment correlation, standard deviation. Right? Anxious. Right? The average. You know what? Do you understand average? Yes. Why? Average is what? Sum them up and divide by number of things. It is average, right? So not only you can compute average, you understand the process of getting average. Are you with me? That's the reason why you are less stressful to communicate and conceptualize average. Why? Because equation, there's like a whole bunch of notation. That's okay. Why? Sum them up everything and divide by number of things. That's average, right? So you know it. Average, right? Let me tell you some magic. Statistic is a house made of averages. So this is a house made of cookies, right? Yummies, right? It's a beautiful house. But each piece is what? Some cookies. Edible. Right? Statistic is what? Scary house. It built on another top of the another thing, another thing, another thing. But in the end, listen carefully. All those beautiful terms, mean, variance, standard deviation, covariance, correlation, slopes, standard errors, and fit indices, I will teach you as a type of averages. I know, in order to compute variance, we need to have a mean. We are creating another average using our averages, mean. Standard deviation, we need mean. So we are using, but still this is a type of averages out of the another averages, right? We have to compute covariance, but covariance need a special type of averages using another means. Correlation, same thing. Slopes, same thing. Standard error, same thing. Fit indices, same thing, right? So whenever you see the equation, let me tell you, is this what is average of what? Are you with me? Whenever you see the equation of variance, what the variance is average of what? Right? What standard deviation is average of what? Average of something. Are you with me? So this is good way of tackle, eliminate, reduce down anxiety about the scary looking statistic house. You can break it down. Divide and conquer. It looks very complicated, but if you make it piecewise, and then you can understand what's going on. Complexity can be conquered by simplicity. All right, look at these gentlemen's. Right, they're very very similar, right? But two data, right, are very similar to each other, right? They're correlate to each other, right? They're related to each other, right? But we do know more than they're just similar to each other. Are you with me? Two data looks a lot, right? Similar to each other, but more than just similar to each other. Why? This drama, the kid is my son. Because the reason why these two gentlemen look so alike is what? He is father of him. He produced by him. I mean, there's a mom, right? There's some big role of some mom, but just like temporarily, and a mom is just watching them, right? Do you understand what I'm saying? We have a theory. Not just two things are related to each other. We have a theory, the reason why two persons are similar to each other is he is father of him. Now we have a theoretical reason why these two persons looks alike. Are you with me? Right? In that case, we have a what? We do have causal theory related causal relationship between two variable. Causal theory of two variable. In that case, we call it as this, not just the variable one and second variable. We call it as this first variable as a what? Independent variable. And then arrow comes in as a dependent variable. We able to explain the dependent variable using independent variable. And we can describe relationship between two variable using this causal relationship, theory related to causal influence each other. All right, that's another analogy. All right, let's talk about simple random sampling. In order to do the simple random sampling, I keep saying what? We need to have a complete list of population. And then sampling is very easy. Why? As long as we have everybody's name in one basket, and then we can randomly sample out of that one basket. What's the biggest challenge? Always, always. Where is that list of students? Where is that list of entire population? Right? So if the business is what? Office of Register. If you're interested in to know student opinion in GW, right, representative way, you have to go to Office of Register. Why? You need to have a list of students and then randomly select out of the students to conduct random sampling. Otherwise, convenience sampling is what? Not representative. One more time. It's a random sampling is a process very easy as long as you have a complete list of people. This is very hard to keep it. Why? People are just jumping around. Sometimes people dying, right? Where is all human beings? I mean, the population list, right? In order to do this, in order to do random sampling, we must have the complete list. So into Office of Register, typically have a list of subject. And then random sampling is very easy. Why? You're sampling name out of that list. That's it. Right? Sampling bias, random sampling has been explained in here. Tableau measurement is measuring running. Okay, nominal, ordinal, interval, ratio, fine. Let's talk about this. How many human beings are running? 3. We call it a count data. To see the world. The world is what? 3 humans are running, right? See the world and processing the 3 humans are running. 3 human beings. If we are assigning 2 for her, 5 for him, and 1 for him, what kind of measurement system we use it? We assigning 2 for her, 5 for him, and 1 for him. What kind of measurement system we are using it? Nominal. We assign number to the thing, but back number type of nominal scale we are go for. Are you with me? And then next one. She is 2 miles, right? And then, he is 3 miles advanced than her. And then the distance between two, like let's say Rachel, right? Rachel, Jehua, Ethan, right? Jehua is 3 miles ahead than Rachel, right? And then Jehua, Ethan is 5 miles ahead than Jehua, right? And then 5 mile differences and 3 mile differences, we only measure in that this distance among those things, right? It will be likely interval scale. Why? We can choose Jehua as a 0, Ethan becomes 5, Rachel becomes -3 if we choose Jehua as a reference point. Are you with me? If we choose Rachel as a reference point, what happened? Rachel becomes 0, Jehua becomes 3, Ethan becomes 8. Are you with me? If we choose Ethan as a 0, what happened? Jehua becomes -5, Rachel becomes -8. Are you with me? If we choose those reference point wherever we want, we call it as a what? Interval scale. Interval scale. And he's first, he's second, he's third, and then we add ordinal scale. Ordinal scale is very easy, right? But let's talk about this. How about there is an absolute starting point, which is 2 miles from Rachel. I'm a Rachel. And then we need to assign Rachel as 2, Ethan as a 5, Jehua as a 5, Ethan as what? 10. Are you with me? Ethan as 10. And then we cannot change starting point. There's absolute 0 exist. And we must go she, Rachel as a 2, Jehua as a 5, Ethan as a 10. In that case, if we assign 2 for Rachel, 5 for Ethan, and 10, I mean 5 for Jehua and 10 for Ethan, we are using ratio scale. Why? There's an absolute 0 point exist. We don't want to change that absolute reference point. It's not a relative reference point. Are you with me? In that case, the numbering system becomes ratio scale. Don't forget this analogy. All right, we already talked about this issue: number of runners and back number for Rachel, rank for Ethan, and distance between Jehua and Rachel, likely interval scale, and location of the Ethan from the starting point, relative, likely what? Ratio scale. Ratio scale, interval scale is very confusing, right? Please don't forget those things. Thank you.